Insulation and grounding are two recognized means of preventing injury during electrical equipment operation. Conductor insulation may be provided by placing non-conductive materials such as plastic around the conductor. Grounding may be achieved through the use of direct connection to a known ground such as metal cold water pipe. The metal housing or enclosure around a motor or the metal box in which the electrical switches, circuit breakers, and controls are placed. These enclosures protect the equipment from dirt and moisture and prevent accidental contact with exposed wiring. There is, however, a hazard associated with housings and enclosures. A malfunction within the equipment, such as deteriorated insulation, may create an electrical shock hazard. Many metal enclosures are connected to a ground to eliminate the hazard, but if a hot wire contacts a grounded enclosure, a ground fault results, which normally will trip a circuit breaker or blow a fuse. Metal enclosures and containers are usually grounded by connecting them with a wire going to ground. This wire is called an equipment grounding conductor. Most portable electric tools and appliances are grounded by this means. There is one disadvantage to grounding. A break in the grounding system may occur without the user's knowledge. Insulation may be damaged by hard usage on the job or simply by aging. If this damage causes the conductors to become exposed, the hazards of shocks, burns, and fire will exist. Double insulation may be used as additional protection on the live parts of a tool, but double insulation does not provide protection against defective cords and plugs or against heavy moisture conditions. The use of ground fault circuit interrupter, or GFCI, is one method used to overcome grounding and insulation deficiencies. The ground fault circuit interrupter is a fast-acting circuit breaker which senses small imbalances in the circuit caused by current leakage to ground and, in a fraction of a second, shuts off the electricity. The GFCI continually matches the amount of current going to an electrical device against the amount of current returning from the device along the electrical path. Whenever the amount going differs from the amount returning by approximately 5 milliamps, the GFCI interrupts the electric power within as little as 1/40th of a second. The GFCI will not protect a person from line-to-line contact hazards, such as a person holding two hot wires, or a hot and a neutral wire in each hand. It does provide protection against the most common form of electrical shock hazard, the ground fault. It also provides against fires, overheating, and destruction of insulation on wiring. With the wide use of portable tools and the use of flexible cords, connectors, receptacles, and cord and plug connected equipment, hazards are created by improper use and maintenance. Flexible cords are more vulnerable to damage than is fixed wiring. Flexible cords must be connected to devices and to fittings so as to prevent tension at joints and terminal screws. Because a cord is exposed, these terminals become more vulnerable. Improperly connected terminals is another common situation. When a cord connector is wet, hazardous leakage can occur to the equipment grounding conductor and to humans who pick up that connector if they also provide a path to ground. Such leakage is not limited to the face of the connector, but also develops at any wet portion of it. When the leakage current of tools is below 1 ampere and the grounding conductor has a low resistance, no shock should be perceived. However, should the resistance of the equipment grounding conductor increase, the current through the body also will increase. Therefore, if the resistance of the equipment grounding conductor is significantly greater than 1 ohm, tools with even small leakages become hazardous. GFCIs can be used successfully to reduce electrical hazards on construction sites. Tripping of GFCIs, or the interruption of current flow, is sometimes caused by wet connectors and tools. It is a good practice to limit exposure of connectors and tools to excessive moisture by using watertight or sealable connectors. Providing more GFIs or shorter circuits can prevent tripping caused by the cumulative leakage from several tools or by leakages from extremely long circuits. There are two basic requirements on construction sites applying to GFCIs. Number 1, a ground fault circuit interrupter for receptacle outlets in use and not a part of the permanent wiring of the building or structure. or a scheduled and recorded assured equipment grounding conductor program covering all cord sets, receptacles which are not a part of the permanent wiring of the building or structure, and equipment connected by cord and plug which are available for use or used by employees. This schedule and recorded assured equipment grounding conductor program must be accompanied by written description of the program, including the specific procedures adopted, and it must be kept at the job site. This program should outline the employer's specific procedures for the required inspections, tests, and test schedule. Electrical equipment noted in the Assured Equipment Grounding Conductor program must be visually inspected for damage or defects before each day's use. Any damaged or defective equipment must not be used until it's replaced or repaired. There are 2 tests required. One is a continuity test to ensure that the equipment grounding conductor is electrically continuous. This test may be performed using a simple continuity tester, such as a lamp and a battery, a bell and a battery, an ohm meter, or a receptacle tester. The other test must be performed on receptacles and plugs to ensure that the equipment grounding conductor is connected to its proper terminal. This test can be performed with the same equipment used in the first test. These tests are required before first use, after any repairs, after damage is suspected to have occurred, and at 3-month intervals. If the cord sets and receptacles are essentially fixed and not exposed to damage, these may be tested at 6-month intervals. These testing and record-keeping requirements may be somewhat time-consuming, so most employers choose to use the GFCI system of protection. Ground fault circuit interrupters must be provided for all 120-volt, single-phase, 15 and 20-amp receptacle outlets on construction sites which are not a part of the permanent wiring of the building or structure and which are in use by employees. Receptacles on the ends of extension cords are not part of the permanent wiring and therefore must be protected by GFCIs, whether or not the extension cord is plugged into permanent wiring. These GFCIs monitor the current to the load for leakage to ground. When this leakage exceeds a certain amount, the GFCI interrupts the current. They are rated to trip quickly enough to prevent electrocution. Whether you choose the inspection and testing method or GFCI method, the objective remains the same: protection from electrocution. Safety on any job site is of paramount importance. Each individual on the job site has a responsibility to inspect all electrical equipment before use, including cords, cables, connectors, receptacles, terminals, plugs, and the equipment itself. Don't abuse electrical tools. Never carry a tool by the cord or hose. Never yank the cord or hose to disconnect it from a receptacle. Keep cords and hoses away from heat, oil, and sharp edges. Disconnect tools when not in use, before servicing, and when changing accessories such as blades, bits, and cutters. All observers or other employees should be kept at a safe distance from the work area. Avoid accidental starting. Don't hold a finger on the switch button while carrying a plugged-in tool. Tools should be maintained with care. They should be kept sharp and clean for their best performance. Follow instructions in the user's manual for lubricating and changing accessories. All portable tools that are damaged must be removed or tagged "Do Not Use." A positive on-off switch can be used only on plate and sanders, grinders with wheels 2 inches or less in diameter, routers, planers, laminate trimmers, nibblers, shears, scroll saws, and jigsaws with blade shanks 1/4 inch wide or less. Other handheld tools such as circular saws, chainsaws, and percussion tools without positive accessory holding means must be equipped with a constant pressure switch that will shut off the power when the pressure is released. Electrical safety when working with electrical is much more than plugging your equipment into a receptacle and beginning work. It's inspecting and maintaining your equipment. It's working safely by following the rules and procedures. It's thinking about safety every time you perform your job. Time for safety because you're worth it. think electrical safety and safety for your fellow employees. Thank you.